Hi friends, welcome to my channel. So next topic is sensitivity. So what is sensitivity? Sensitivity is the ratio of change in output of an instrument to the change in input. Means sensitivity denotes the smallest change in the measured variable to which the instrument responds. Okay, so the manufacturers specify sensitivity as the ratio of magnitude of measured quantity to the magnitude of the response. The ratio is called inverse sensitivity of deflection. Sorry. So that is the sensitivity, initial change in output to the initial change in input. Okay, and that are the linear input output linear curve. So that denotes the sensitivity, but curve is not actually same as that, but also there that kinds of. So if that case, their sensitivity denotes that kinds. Okay, so if the calibration curve is linear, means the calibration curve is linear, then the sensitivity of instrument is the slope of the calibration curve. Okay, slope of the calibration curve. And if the calibration curve is not linear as shown here, then the sensitivity varies with the input. So inverse sensitivity or the deflection factor is also defined as the reciprocal of the sensitivity. Means inverse sensitivity or the deflection factor is equal to 1 upon sensitivity. Means inverse sensitivity means initial change in input to the ratio of initial change in output. Okay, so that is the sensitivity. Okay, after that we'll discuss the linearity. So what is linearity? Linearity is defined as the ability of an instrument to reproduce its input linearly. Means the linearity is defined as the ability to reproduce the input characteristic symmetrically and the linearly. Okay, the curve shows. Okay, input versus output curve, if there are linear, then the linearity becomes true, but actual curve was not linear. The actual curve is that kinds of. Okay, so percentage linearity is defined as the maximum deviation of output from idealized straight line to the full scale reading or actual reading. Okay, so linearity is simply a measure of the maximum deviation of the calibration points from the ideal straight line. Okay, and accuracy and linearity are closely related to each other, hence the instrument should be as linear as possible so that it result in small errors. Means linearity is maximum, then error will be reduced. Okay, so that is the linearity. Okay, next is hysteresis. So what is hysteresis? Hysteresis is a phenomenon which depicts different output effects while loading and unloading. Means hysteresis is the phenomenon under which the measuring instrument shows different output effects during loading and unloading. Hysteresis results from inelastic quality of an element or device. Okay, so hysteresis takes place due to the fact that all the energy put into the stressed part when loading is not recoverable while unloading. Okay, so it is the maximum difference between corresponding upscale and downscale output from any single test cycle. That is the maximum difference in output at any given value of the measured variable within the specified range when approaching that point, first with increasing the input and then decreasing the input. Means when the input of an instrument is varied from 0, means here varied from 0 to its full scale, and then if the input is decreased from its full scale value to the 0, the output varies. Okay, input, if input change then output also varies, means the output at the particular input while increasing and decreasing varies because of internal friction or hysteresis damping. Okay, output है वो चेंज होता है क्यों, इंटरनल और इंटरनल फ्रिक्शन और डैम्पिंग की वजह से. और okay, so the difference between two curves is called as hysteresis. Okay, so hysteresis in this first maximum that called maximum output hysteresis, means first output reading and curves between output reading and input. Okay, so first 0 to increase, then decrease to full value to 0, and then that and so on. So that is the hysteresis. Okay, so input is output is varies according to input value. Okay, so that curve is called is hysteresis. Okay, next is reproducibility. Okay, so reproducibility is defined as the degree of closeness by which a given value can be repeatedly measured. Okay, and it is specified in terms of scale reading over a given period of time. Okay, perfect reproducibility signifies that the given readings that are taken for an input do not vary with time. Okay, so reproducibility means degree of closeness, means number of, there are lots of number of result. Okay, so reproducibility means closeness to repeatedly measured, means one quantity is repeatedly measured, then how close to the reading, output reading was taken, that is the reproducibility. Okay, next is repeatability. So what is repeatability? So repeatability is the measure of closeness with which a given input can be measured over and over again. Okay, so it is defined as the variation of scale reading and random in nature drift. Drift may be classified. So drift, what is drift? First, repeatability is defined as the variation of scale reading and it is the random nature. So repeatability is the difference in the scale reading, means input is vary over and over, and how much output will difference, that is the repeatability. So what is drift? So drift is defined as the gradual shift in an indication over a period of time where in the input variables does not change. Okay, drift is what? Drift is change in the output at that input not varies. Okay, so drift is defined in three category. First one is zero drift. So what is zero drift? So zero drift is the deviation of the output from its zero value when the variable to be measured is constant. So if the whole calibration gradually shifts due to slippage, permanent shed, or due to the undue warming up of electronic tube circuits, zero drift sets in. Means what is zero drift? Here, that is the zero drift. Okay, so characteristic with zero drift was there, but nominal characteristic is that kinds of. Okay, so that is the zero drift. Next is span drift or sensitivity drift. So if there is proportional change in the indication all along the upward scale, the drift is called as span drift or the sensitivity drift. Okay, so span drift is the change in indication along the upward scale. Okay, here the span drift is scale change. Okay, so nominal characteristic is here, but span drift along the span drift characteristic, that is the that kinds of. Okay, third one is zonal drift. Zonal drift is the drift that occurs over a portion of the span of an instrument. Okay, and in case the drift occurs only a portion of span of an instrument, it is called as the zonal drift. Okay, so that is the drift, means change in output over a input is constant. Okay, next is resolution. So what is resolution? So if the input is logically increased from some arbitrary input value, it will again be found that output does not change at all until a certain increment is exceed. This increment is called as resolution. Means the output means slowly increased, means सपोज हम स्लोली इनपुट को हम वेरी करते हैं, ठीक है, स्लाइटली चेंज करते हैं इनपुट में, तो आउटपुट है वो चेंज नहीं होगा. मीन्स मिनिमम चेंज हमें जो करना पड़े इनपुट में ताकि हम आउटपुट चेंज कर सके, उसको हम रिजोल्यूशन कहते हैं. ओके, सो इट इज द स्मॉलेस्ट चेंज इन द मेजर्ड वैल्यू टू विच द इंस्ट्रूमेंट विल रिस्पॉन्ड. मीन्स हम कम से कम जो हमें चेंज करना पड़ता है इनपुट वैल्यू को, जैसे हम इंस्ट्रूमेंट रिस्पॉन्ड कर रहे हैं आउटपुट में, उसको हम रिजोल्यूशन कहते हैं. ठीक है, thus the resolution defines the smallest measurable input change, while threshold defined as the smallest measurable input. Okay, so threshold, what is the threshold? So if the instrument input is increased very gradually from 0, there will be some minimum value below which no output change can be detected. This minimum value defines as the threshold of the instrument. So resolution क्या है कि resolution हमें जो कम से कम जो चेंज करना पड़ता है इनपुट में ताकि हम आउटपुट इंस्ट्रूमेंट रिस्पॉन्ड कर सके, आउटपुट चेंज हो सके, उसको रिजोल्यूशन कहते हैं. और थ्रेशोल्ड क्या है कि कम से कम इनपुट हमें चेंज करना पड़ता है ताकि आउटपुट में कोई भी चेंज ना आए, उसे हम थ्रेशोल्ड कहते हैं. ठीक है, नेक्स्ट इज स्टेबिलिटी. सो स्टेबिलिटी इज द एबिलिटी ऑफ एन इंस्ट्रूमेंट टू रिटेन इट्स परफॉर्मेंस थ्रू आउट इट इज specified operating life. Okay, so the ability of an instrument to retain its performance throughout its specified storage life and operating life is called as stability. Okay, so stability क्या है कि हमें मैक्सिमम उसके इंस्ट्रूमेंट की लाइफ के मैक्सिमम जो एबिलिटी है इंस्ट्रूमेंट की कि वो अच्छा परफॉर्मेंस दे सके, उसे हम स्टेबिलिटी कहते हैं. ठीक है, नेक्स्ट इज टॉलरेंस. सो व्हाट इज टॉलरेंस? टॉलरेंस इज द मैक्सिमम अलाउबल एरर इन द मेजरमेंट इज स्पेसिफाइड इन टर्म्स ऑफ सम वैल्यू व्हिच इज कॉल्ड एज टॉलरेंस. ओके, सो इट इज द मैक्सिमम अलाउबल एरर दैट इज स्पेसिफाइड इन टर्म्स ऑफ certain value. Okay, and it specified the maximum allowable deviation of a manufactured device from a mentioned value. Okay, and next is range or span. So what is range or span? I hope you may be familiar with that. The minimum and maximum values of a quantity for which an instrument is designed to measure, it's called as range or span. मीन्स जो हम इंस्ट्रूमेंट को हम डिज़ाइन कर सकते हैं कि मिनिमम वैल्यू हम इस 0 से 30 तक हम मेजर कर सकते हैं, तो 0 इज मिनिमम वैल्यू एंड 30 इज maximum value. So 0 to 30 is span or the range of the instrument. Okay, I hope you understand very well. If you not get, then contact me. Okay, thank you. Next topic will be discussed in the next video lecture. Okay, thank you.